Hi, so I'm Andres. I work these days for Citus Data. I joined them a couple of weeks ago. I used to work for Second Quadrant, and I spent my days mostly hacking Postgres, which is great. So first, one thing what we now have in 9.4 is the so-called logical decoding, which is basically the basis for various replication systems. You can do all kind of things. Other databases call that change data capture. That is, I think, what MS SQL calls it. Oracle's Golden Gate is based on a similar technology, and we now have that. And what it allows you to do is to get all the changes as they happen in the database. And you can configure it, how those changes look like. But the problem is that it's very, very low level. You have to write C to consume those changes, which obviously excludes a couple users there. I hope there's people starting to write those output plugins. There's now an output plugin which feeds directly into Kafka, which is pretty cool for some use cases. There's one that feeds outputs everything as JSON, but it's not a replication solution. It's just the basis for building a replication solution. The cool thing is about it, it's pretty efficient, and it gives you a couple features that are very helpful for building a replication solution. And it's better than what the existing logical replication solutions for Postgres have to do to get where we are now. And they were great, because otherwise, without Sloaney, without Londista, we wouldn't be where we are today. But still, they had to do nasty stuff with triggers, nasty stuff to get the ordering right, and all that causes a couple problems. So what we try to do now, or what we built on top of logical decoding, which is in 9.4, is a set of two replication solutions. It's UDR and BDR, and I'm to blame for those names, unfortunately. And UDR stands for unidirectional replication, and BDR stands for bidirectional replication. Originally, that was just a working name, and somebody was supposed to come up with a better name, but apparently nobody did. And so we are here today. And it's built on top of logical decoding, and which has some of these advantages. The write overhead over not running replication is like usually in the 2% range, whereas with solutions like Sloaney or Londista, you're on the 150% range, which obviously can make a difference in the val volume and the disk volume. The other stuff is like we can support synchronous replication, which is not possible with Sloaney. And what we try to do while building this out of core is to build it in a way that we can move more and more infrastructure into core Postgres, because we think that it's very important that Postgres can replication out of the box and can do it in a very flexible way. It's good that there are solutions out of core that can do all this, but it makes it so much more complicated to get there. On the other hand, it's very hard to develop features for Postgres. It is a multi-year effort. It has to work very well, and that means that it just takes ages, and it's very hard to get actually people to finance that doing something. Hey, we're working for the next 4 years on a replication solution, and then it will take another 2 years until you can actually use it. So yeah, that's why we got some part into core and then build something out of core, and we are now integrating more and more features into core Postgres. In 9.5, we have a couple efficiency features for replication, and we have the basis for DDL replication in 9.5. So, and it's important to say, just out of fairness, that the most of the work here was done by Second Quadrant or by Second Quadrant employees. Initially, it was me working on this full-time for 1.5 years or so, and then you got more and more people, and a good part of that work was sponsored by Intel Security, then still known as McAfee, and by Adyen. So how do these solutions fit together? We have Postgres 9.4 with the aforementioned logical decoding. We have now background writers, which means we can integrate additional logic into the database and can control things from there. And then we have UDR, and UDR works against stock Postgres 9.4, and it provides replication with stock 9.4. And but it only supports primary standby or hot and passive, or however you want to call it, type of replication. And that's pretty good for some things, not for everything. It's relatively efficient. Unless you have like 16, I think we had 64 processes on a 64-core machine, and we couldn't make it not keep up with replication until like 60 clients or so. And with the equivalent with Sloaney and Lundista was around 15 or so. So the overhead is much lower, which is good. And what also is important, especially if you compare it with the built-in streaming replication, you can use UDR to replicate from 9.4 to 9.5, if there were a released 9.5, which there is not yet. And what's also important in comparison to the existing solutions is that you can create a clone from a new standby or from using PG-base backup. Especially if you feel like a very large database, say you have a database with a couple terabytes, it's very cumbersome to copy all the data using with Sloaney or Lundista or with pgdump, because that takes ages. But if you have a base backup, that can be much faster. And I think that's my favorite part of this. And then on top of that, basically using most of the core that is in code that is there for UDR, we have BDR, the bidirectional replication part, and that unfortunately requires modifying Postgres, so it comes with a modified Postgres 9.4. And what we said is it's not really a fork, because all the changes that have been made to Postgres have been sent upstream. A good number of those have been integrated into Postgres 9.5. And Simon one night came up with a great name that's not a fork, it's a spoon, because we're following Postgres so closely. And yeah, and what it does active-active replication in an asynchronous manner, which means it's suitable for distributed workloads where you have one node in one data center and in one continent, and another node in a completely different continent, which is very hard to do with some of the other solutions which require very close low latency between the nodes. And what's also pretty cool is that it supports DDL replication, which means that you can execute create table, and the table will immediately be replicated to all the standby or all the other masters and be available there. You can even execute alter table, at least for most alters, and that makes it much harder to screw up your replication scheme. I don't know how many people in here use Sloaney or Lundista. Who of you has not managed to break your system by forgetting to add a column here and there or something like that? Okay, nobody.
Not for a while.
But yeah, it's very hard, for example, to rename a column or drop a column without breaking anything. So that's why I think it's very, very important that DDL replication has to be part of a replication solution. It's also important that DDL replication is not really, has to be not part of multi-master, it's just that you have to modify Postgres for it. But now in 9.5, all the prerequisite features for that are in core, so we can now do that without modifying Postgres, which means in 9.5, this feature will basically drop down to UDR. So what do you have to do to use UDR? You have to do a couple configuration changes on the individual nodes. These changes are pretty similar to what you have to do for normal streaming replication, because there's actually quite a lot of common code between streaming replication and UDR or BDR. Then you have to subscribe a node to the primary, which means it will require get all the changes that the primary make and have been made on the primary and replicate them. And in the process of that subscription, it will clone all the existing data, move while the master is continuing to accept writes, and build up the existing data on the standby, and then at the end of that, it will catch up all the data, changes that have been made since. And it's important to know that, as I said before, that you can clone the data either by just using BDR, an SQL function, then it will clone the data, or you can use a command line tool, and that command line tool can use a physical base backup either by doing it itself or by pointing at an existing base backup. So what are the prerequisite configuration steps? You have to allow that changes are streamed out, which means you have to set max val senders to some number higher than the standbys you use. That's the same configuration variable you have to set for streaming replication. Then there's a new variable for 9.5, which is 9.4, which is the max replication slots, which basically are used to keep track of which data has been streamed to which node and how much data has to be retained on the master. And then you have to load BDR or UDR. They're named the same binary to make it available. And one last step is that you have to set the val level, not just to hold standby, which you have to do for streaming replication, but one level higher, which is logical. Logical does not have any overhead if you only do inserts or updates without changing the primary key. If you do updates while changing the primary key, it will have a bit of overhead because it has to log the old primary key and the new primary key. And for deletes, you have to. It always has overhead because now the update, not only the physical location has to be logged, but also the primary key. And you have to allow the other node replication access. So just as a preparation, we just can make sure that the val level is set accurately, that replication slots are set, and so on and so on. And then those are the important parts. We want to create the extension BDR, because BDR can manage completely from SQL. And so we have an extension that has all that knowledge. And unfortunately, it internally requires that the B-tree gist extension is installed. And if you don't manually install that beforehand, it will say dependency not fulfilled.
What does it use B-tree gist for?
An index that is both over ranges and over normal columns. And that's not possible otherwise. I wish extensions had an automatic dependency mechanism so that if you type BDR...
Long-ass arguments on hackers.
Yes, I know. I still wish it were true, even if there were arguments about it. Yes. So and just to make sure we have some data, we can just create a table and insert something. And now comes the important part. On the standby, we have a function called BDR.BDRSubscribe, which means that this node, the standby, connects to the master and does all this cloning of the existing data and then receiving all the changes from there on. So what you have to do is to give the local node a name. And that's mostly important for knowing which node to drop later on and to see it in like some statistic views. Then you have to say, to which node are we subscribing to? And here you have to enter a connection information. So if it might be just the host name of the other side, or you could also just have to specify the username, SSL client certificates, the port, whatever. It's just the normal syntax for that. And which might confuse you a bit, you also have to specify the local DSN, which is how can another node or another utility connect to the local node. Because unfortunately, to load the data into Postgres, we have to connect to Postgres, and there's no API how to connect to Postgres directly without using a DSN or connection information. And that will then start and do all the work in the background after it has done some basic checking. And as it's in the background, you can wait for the result using no join wait for ready. I don't know, that function is too long, but whatever. And when that's done, it will have the existing data and from there on, you can receive changes. So how does this actually work? You have the primary, and you have an empty database. When you do that subscribe call, it will connect to the primary, check that the primary is configured correctly. It will check that the empty database is configured correctly, and then it will go and create this replication slot on the primary. That means from there on, once that slot is created, it can receive all the changes that are made afterwards. Then it will start copying the data. And that is possible because when you create a slot, it gives you a snapshot back of how the data looked while you created that slot. And then the data is copied. And after the copy is finished, you can get all the data from the slot that has been changed since that initial snapshot. And after that, you have a finished standby. So I said earlier that UDR does not have DDL replication, which means that if you execute the create table fail here, it will tell you that for UDR, you are not allowed to execute DDL without setting the I'm doing dangerous flag. So obviously, you will need to be able to execute DDL. So what we have is a function, BDR replicate DDL command, that you can just pass an SQL string, and that will be then first executed on the primary. There will be some correctness checks, whether it's somewhat likely to be unambiguous. One of those checks is that you have to specify the schema because the search path might be different. There might be different tables on the standby, so you have to qualify everything fully, and then execute the command on the primary and then on standby. And that's transactional. So if you do an abort afterwards, rollback afterwards, that works just fine. So that's, I think, the most important part of how to work with this. And one last really important thing, what if things go really, really bad and your primary is down? You obviously don't want your standby to continue trying to connect to that primary. You have to tell it, oh, I don't want to receive changes anymore. And there's this somewhat oddly named BDR part by node names. And you can pass it the name we configured earlier. And that makes it independent of the primary. And the reason unfortunately, it's not BDR unsubscribe or so, because this is the same function that's used in BDR, and we haven't yet made a separate copy of that. We should have a BDR unsubscribe that wraps this, but there's always work to do. Yeah. This is the basic functionality of UDR. But in many cases, you don't want to actually replicate all the data in a database. A common case is that you have a log table, you have session data, and these you don't necessarily want to replicate over the Pacific because even your big dark fiber costs money or has limited bandwidth. So what you can do is configure replication sets. A replication set is basically just a name for a set of tables. Every table can be in several replication sets. You can say, for example, there's one replication set, important data, and all the important data that you need because that's critical for your business is in the important set. You can also have another table that has just the log data because you have a system that aggregates logs from several other systems, and you want to receive those, and so on. And there's two implicit replication sets. There's the default replication set, which is every table is automatically part of the default set unless you configure a different replication set. And that's really useful because it means you can say, I want to replicate all the tables in this set or just ones that are newly created. Because a common case with deployments when you have with Londist or Slony that I've seen is that people add a new table and forget to add them to the replication. And then a couple of months later, there's the primary dies, and suddenly you are without the important table that you have added. And there's the all replication set, which is pretty obvious. how can you use them? What you do is, when subscribing to the other node, you have another parameter, and you can say, I'm subscribing to the replication sets default, which means every non-configured table and all the important tables. And it will replicate all changes to tables that are either in default set or in the important set or in both. That's fine. They can overlap. But so far we have no table. All tables are in the default replication set, so we have to associate tables with replication sets. That you can do that by using the BDR. Oh, there should be a select there. I cut off the select. Sorry. It should be select BDR table set replication sets, and for the session data, we, for example, can use the volatile replication sets, because it's not really important to replicate it for durability purposes. But for example, if you have a standby that's also queried for read queries, you still might want to find your user sessions. In that case, you want to replicate also the volatile data. And then for another table, we assign the important replication set. And for a third table, we do add two different tables, replication sets. And yeah, I think that's pretty obvious what it does. You can call a table get replication sets to get all the replication sets, which is also, obviously, there's no second parameter there. Yeah. Unfortunately, at this stage, there's a couple pretty important dangers when using replication set. And the most important is that even if you specify, like here, a subset of a couple replication sets, the initial clone during the subscription will copy all the data. And that's because we currently use internally pgdump to do all the copying, because we didn't want to re-implement that because we had limited amount of time. And it's very hard to make pgdump copy certain tables and not fail during restore due to foreign keys or something like that. So for now, it copies all the data. But only the subscribed tables are updated, which means that if you might have had at the moment stale a couple tables that are not subscribed, which then after a while will contain stale data. It's also important that changing the set subscription currently requires a restart. There's a function that you can use to change it, but at the moment you either need to kill the apply process manually using pgterminate backend, or you need to restart. That's going to be fixed in the next release. And the probably most bothersome restriction is that if you say after a while, okay, I'm moving this table into a different replication set, it will not automatically resync the table even if it at the moment contains stale data. That's also to be going to be fixed. Just to make clear, when I say that changing the set subscription requires a restart, that means changing which this here requires a restart. You can change which table are in which set at runtime without any problems. Yeah, so this is basically UDR. Then let's go on to BDR. For BDR, it's generally to know it's very similar. It's basically the same code bases. We just have added a couple features, and it's not unidirectional but bidirectional. So what you don't do, in contrast to UDR, is you don't subscribe to one other node, because that basically implies that changes flow only in one direction. What you instead do is you have a group of nodes that replicate changes in all directions. So what you do in the first node, you create a group, and all the nodes from there on join a group, and thereby connect to all the existing nodes and configure replication for all of them. So it's basically the same configuration. All the first steps are the same. What you additionally have to do is to turn on the feature track commit timestamps to on. That has, by the way, been integrated into 9.5. It unfortunately has been renamed at the same time, but so is life. And there's also a very helpful feature that we possibly should default to on, but I will explain in a second why it's a good idea to turn that on. So on the first node, what you do is as I said, you create a group of replicas, and the first node, a group of one is not yet a group, but so you create the group. There's no existing group to join, and again, you give the node a name, and you have to again say, how can this node be reached? And this is important because if you join a network of 10 nodes, you don't want to have to specify the DSN of all those 10 nodes, but instead you say, I'm connected to one other node, and then it will figure out all the other nodes and automatically configure that. You can override that, but by default, it will do all that. So the BDR group create will not really do much, except check that this DSN actually works, and that this node name is unique. So on the further nodes, what you do is, again, do the same game. You create the btree.gist extension, you create the BDR extension, and then you say, instead of BDR subscribe, you say group join. You give the local node a name. You can say, how can I connect, what's my own DSN, how can I be reached by the other nodes? Because obviously, if the data has to flow in all directions, the other nodes also have to connect back. That's what you specify here. That's why it says node 0.2, and you have to say from which node do I want to clone the data and the connection information. In this case, we want to clone from this node here. And then it will do the same game. It will copy all the data. It will then afterwards catch up all the changes that have been made since. And after you can use the same function, the wait for join node ready monstrum, and to wait for it. And then if you want to do that on another node, say you want to go to node 3 and do the same game again, I give the local node a name, I say how can I be reached, and then here I say from which node do I want to clone. Earlier there was only one node I could clone from, but now there's two. There's 101 and 02. So this does not change any persistent topology. What it does is determine where do we get the initial copy of data from, which might be important if you have one node on one continent and one node on the other continent. You might want to clone from the node that's on the same continent as you, because that will be much faster than doing it over a long distance. But after that, it will not have any effect from which node you cloned. Yeah, and at this point, you have a network of 3 BDR nodes, and all of them replicate changes into all directions. And here is another difference. Because BDR does DDL replication, you don't have to use this annoying function to replicate the changes. What you instead can do is just do the create table, and it will work without any errors. And you can even alter table, add columns, also just works. But there's a couple of things that don't just work. Because BDR is configured, and UDR are configured on a database level. You don't replicate entire clusters, you replicate individual databases. There's the problem that Postgres has these annoying objects that are not on database level, but on a cluster level. For example, users are are shared between databases. So we can't easily say this user has just been added, we replicate it, because it might not be relevant on the other side. And we also the user might get created in a database where BDR is not configured, so it can't even know that it replicates changes to another node. So you have to replicate user changes manually. Or you can use the same function that we used for UDR earlier to replicate the user change. Same thing is for table spaces. They are also cluster-wide and can thus not be automatically replicated. The third object is database creations themselves are not replicated, but that's pretty boring. And if you execute a command that cannot be replicated, and there's a couple that can't, then you will get an error. And the ones that basically can't be replicated are the ones that would be inefficient. For example, if you do an alter table and the alter table requires a rewrite of the entire table, to do that safely, we would have to re-replicate the whole data table, because not all of these rewrites of the table are side effect free, and there might be a random, there might be column defaults and whatever in there, and they're recomputed. So that's what we don't support. And there's one thing that's important to know, which you can disable, but if you do DDL on one node, it will prevent DDL on all the other nodes at the same time. There's a so-called global lock across all the nodes, which implies two things. A, other nodes can execute DDL, and B, all the other nodes have to be up to execute DDL. And the reason for this is a really annoying requirement, but it's basically also very important if you are not very, very careful while executing DDL, because if the other node has pending changes and you just renamed a column, you can't necessarily replicate all the pending changes, and then you have a even bigger problem. So for now, all the schema changes require a global schema lock. At the moment, exempt are temporary tables and you unlock tables. Yes, those are pretty much the only thing that I accept. We hope to make this more granular. For example, there's a couple commands that you don't really need the full schema lock, where we could say, okay, I only want to log individual objects against schema modifications, but we haven't yet. Yeah, and the infrastructure for doing DDL replication is now in 9.5. So for 9.5, you don't have to patch Postgres anymore, which means UDR for 9.5 will get DDL replication in the same way BDR has it, or actually in hopefully a bit better way, because while integrating it, we improved the feature. Yes. So as I said earlier, that BDR is an asynchronous multi-master solution, which means that you make a change and it can take a while till other nodes have that object, have that change. Which obviously means that if you do the same operation on 2 nodes or more nodes in the network, there can be conflicts. You can update the same row and you have to somehow first detect that that happened and then resolve that conflict. By default, BDR does that with a relatively simple mechanism called last update wins, which means if the last update wins, if there has been a primary key conflict, we don't actually fail. You can enable that, but by default we don't fail. We turn the second update, insert into an update of the existing row. If you do both nodes delete a row, the later delete basically takes effect and the first delete is ignored, and that kind of thing. It's important to know that the timestamps here are in a way unambiguous, which means like even if you have clock drift between 2 nodes, they will both decide that the same update wins. It will not be the case that because the clock goes differently, a different row will the different version of the row will survive. And that works because we basically decide which row version wins by looking at the reported time on each node. And so the effect that a wrong clock can have is the wrong row wins, but it will win on all nodes, which is not perfect, but usually you have clock drifts around a second or something. If you use NTP, that is not that bad. You can also just install additional conflict handlers, which basically are like triggers that are called when there's a conflict. You will get the different versions of a row. You can then say, okay, this was such a bad thing, I want to stop replication because otherwise my database is corrupt. Or you can say, hey, I like this version more. Or you can even say, I want to return a new version of the tuple. In some cases, if you see both versions, you can just say, oh, I want to merge a column, for example, because you just append it to an array, and then you can build the array or a set, and then you can build the union of that set. And you can also enable that conflicts are logged to all tables. That is that GUC, the configuration option, BDR log conflict options to table, and which you can query, which will show you we had this row, and on the one node it was named had this content, on the other node it had this content, and which time did that happen, and how did we resolve it. That's stored in JSON because it was easier to store that because we needed to have one table that can contain tuples from all different schemas and tables. Yeah. And one thing is that a common problem when you insert rows into different nodes, from different nodes into the same table, is that you have an ID column or a key column, and you want that to be unique. What you can do is either just use normal sequences in Postgres and just say one node uses even numbers, the other node uses uneven numbers. Or you can say I'm using a UID as primary key. But all those have a couple advantages and disadvantages. For example, with UIDs, usually your primary key performance can go down. You can and it's very hard to see insertion order, even if it's not accurate. So some people don't like UIDs and similar as auxiliary keys. So what BDR has is so-called distributed sequences, and they are conflict-free between all the nodes in a BDR cluster. So if you do a create sequence using BDR, it will ensure that the values that are returned by the sequence are unambiguous between the nodes. And because it would be very inefficient to reach out to other nodes to ensure that you're unique for every single new value, we do that in blocks. And these blocks are at the moment 1,000 big. And so one node will get 1 to 1,000, another node will get 2 to 3,000, and so on. And that's done by a majority vote. So you can't have conflicts. It still works if some nodes are down, but if all the other nodes are down, or if you are partitioned away from the rest of the network, at some point you are going to run out of values, and then your insertions or your next vol calls will fail with an error message. At the moment, we don't wait. It's also the case that we don't not just associate blocks of 1,000 to a node. We actually associate 15 of those blocks. And we do that because then we can continue voting on the next block while the existing block R is still used. And it also allows to survive temporary outages. If your network goes down for a minute or 5, you might be fine with having 15,000 values available, but just 1,000 is probably not going to cut it. We are working on making these sizes and the pre-allocation configurable, but so far that has not been the highest priority. Again, we are working on integrating the abstraction for saying this part and for being able to do this in a voting fashion into Postgres. It nearly made it into 9.5. I really, really hope that Postgres 9.6 will have that feature built in. As I said earlier, you are not used to use the SQL interface. There's also a command line interface, which does start from a physical backup or a PG-based backup, or using a manually required one using any other tool, Barman, rsync, whatever. And there's the tool called BDR init copy that can do the base backup itself, or you can point it at an existing backup, and that will be basically do the group subscribe or the group join or the node subscribe itself, and then bring up the base backup into the existing either group or join to the other master. One important thing to know there is that if you use BDR init copy, that it will potentially contain all the databases that are in the source, obviously. If you run that, it will only connect to the database you name there. So it's better to do that if you only have one database per cluster, but I think in production that actually is much more common than having multiple databases. So it's probably okay. And the way it works is that if we create first the base backup or use an existing one, then create the logical slots, and then we catch up using the physical stream replication, all the pending changes that have been made since the base backup has been created. And once that's done, we are up to date and then can catch up the rest of the logical changes because we created the slots beforehand, and then it's up to date at the end. Yeah, that's mostly interesting if you want to do large databases. Yeah, and then we can use especially UDR for cross-version upgrades once 9.5 is released. Because the replication protocol between the clusters is version independent, it will automatically downgrade its efficiency because by default, BDR or UDR replicate the changes in like in the low-level format because it's assumed they're the same unless your version mismatches, unless your architecture mismatches, then it will automatically fall back to using the text protocol, which Postgres basically guarantees to be safe because we use it for everything else. There's a couple caveats. If you do upgrade BDR nodes individually and do DDL replication, the old node can't know that possibly a syntax could have been changed in the new version. So you could run into trouble there. I would just advise to not do too complicated DDL as long as you run different major versions. But on the other hand, Postgres doesn't really do that many, doesn't break DDL across major versions that often anymore. So we'll see how that works out in production. At the moment, it's relatively hard, unfortunately, to use a physical clone to do the major version upgrade. It would be very, very cool if you could do a PG base backup, then do a PG upgrade, and then rejoin that. That's basically actually possible. We just don't have the scripting around it. All the internals are there for that. We just have to provide a tool that does coordinate all that. So when do you use BDR? A very good, I apparently lost a couple of points here because that was earlier this long. Oops. So whatever. A typical use case is that you just want to do easier failover and failback. You actually don't use real multi-master. You just say only this node is allowed to receive changes. But then you say, OK, for some reason, I want to do something else on that node, or it's down. So I'm repointing the write to the other node, and we'll continue writing there. And you can switch that around, and it will catch up the pending changes. Obviously, if you switch the writes to the other node while the one existing node is down, there can be pending changes that will then be tried to re-replicate when the other node is up again. But in many cases, that's fine, especially if you say, OK, for important changes, we are going to use synchronous replication anyway, or we use 2PC anyway. In those cases, it's pretty much fine. You have to analyze, though, whether that's fine for you. As mentioned before, the reason we actually start to work on this is that more and more companies have data centers all around the world, and they have a core of the data that's used on all those, and just going from one side of the world to the other just takes time and makes the applications very sluggish. So what they want to have is a local copy of the data and be able to modify it on each site. And the application basically guarantees that conflicts are either unimportant because they're like, the initial use case was that somebody updated a spam policy. The spam degree could, in theory, be changed on 2 continents. If 2 people logged in on both sides and changed the same setting, then the later one would win. That's not particularly bad. And all the rest of the data would be separate for modification purposes and then just brought together for querying. In those cases, it's perfectly fine to use async MM. The other cases are where you actually guarantee that your data is unique between the clusters for modifications. For example, you can say if you have go to your store website and you say, I'm from this country, all your writes have to go through a specific cluster, but they still can all query the same metadata about what you have in stock and things like that. Or if you are insertion only and you don't have any unique constraints that can be violated between nodes, then it's also relatively easy to use this. There's obviously other cases where you don't want to use something that defaults to last update wins. If you have very high consistency requirements between for the whole data, then you should think very carefully before you use something like this. Yeah. So what are the upcoming things? The highest priority, I think, has that you can be more granular when cloning the data, when subscribing, that it will only subscribe to the tables, copy the tables that you subscribe to, and that you can resync the data when a node is added to a replication set that is not yet available on the other nodes. The other one is that while the documentation has been much improved over what there was earlier, it's still not perfect. It's at least not in the wiki anymore, which was the probably biggest mistake in the development of BDR UDR, was trying to use the Postgres wiki for documentation. There's a couple of usability improvements. If you want to join a node, Josh reported that it would be very nice to not only see the error messages in the Postgres log, but see those at the screen directly, that kind of thing. And adding the DDL replication for UDR is one thing that is coming. And then what I find a very cool feature, but maybe I'm just weird, is basically doing 2PC over the asynchronous multi-master. So you can do, say, I want to do this transaction and it's very, very important. And then it will internally use 2PC to guarantee that it's applied successfully without conflict to all the nodes, and only then return success to you. So what can happen is that your transaction fails because of a constraint violation or something on another node, but you will not get a commit and then have your changes conflict with another node and with a change on another node. I find that a very appealing feature. So you can say we have a very low rate of very important things where it's okay that it takes much longer, where I have to connect the other nodes, but for most data, I don't need that. I think for that will be a very cool feature. Yeah, and one of the bigger things slightly is that we want to move more and more of that into core Postgres. Obviously, the API in core Postgres is not going to be BDR subscribe, but something else. But we work very hard to make all the pieces that we integrate into Postgres general enough to be reusable. Yeah, I think that's the bigger features that are coming down. Yeah, the documentation is on bdrproject.org/docs. It also has links to and instructions for RPMs, for Debian packages, and for installing from source. Yeah, you can find more general information on the BDR project website. This is actually just a redirect to the Second Quadrant website about BDR. Second Quadrant provides support for this. If you run into issues, there's a GitHub with issue tracker, and these slides are here. Other than that, I think I'm done.